Okay.
It should be going soon. Okay, there you go.
Hello, everybody. We're going to be reviewing GH-1810 optimizations for unreachable sentinels today. This is an optimization change. It's not for correctness, so looking at the standard won't be a primary guiding feature here. We're going to just be making sure that implementing these optimizations doesn't break any of the requirements that the standard requires. First, a little bit of background. Let's talk about what is an unreachable sentinel. Well, as you may know, the ranges proposal added this notion to the standard library that an iterator and sentinel type are the things that denote the beginnings and ending of a range, as opposed to necessarily just being an iterator pair, as was the case in C++ 17. The unreachable sentinel is a special type we added to the standard library that has a comparison operator that always returns false. Right, so no iterator will ever be equal to this unreachable sentinel, which implies that it's an infinitely long range. This is sort of a newish idea, although I guess technically input ranges were allowed to be infinite, right? It's possible that incrementing the iterator never actually compares equal to the end iterator of an input range, so it's not a completely new idea. But anyway, this unreachable sentinel is a handy kind of thing because it allows for optimizations of the sort. Yeah, here's the example on CPP references. It's actually pretty canonical, where if I have a const char star, right, a pointer to character that I know points to a null terminated string, and I want to find the null terminator, how would I do that using std find in the standard library, right? If I don't have an end iterator to pass that compares to it, well, this is exactly one way to do it. You can pass to std ranges find your char pointer and an unreachable sentinel, indicating that there's effectively no end to this range as far as find is concerned. You want to keep looking until it finds a character equal to a null character, regardless of how long it takes to find it, right? Just keep looking. So this PR presumably is going to add optimizations for unreachable sentinels to algorithms themselves to avoid some comparisons, I guess, in cases where the in sentinel is an unreachable sentinel. Any questions so far? Let's look. Oh, Mia just linked the PR in chat. That's not a question. All right, I'm going to move you guys off on another screen, and I'm going to share my screen to the 1810 optimizations for unreachable sentinels, and we're going to go ahead and jump right in. I'm going to get an overview first by collapsing everything, which I greatly like to do. We're going to touch 4 headers and 5 test files. It looks like fairly extensive changes in all of these files, so let's pick one and dive in. All right, this first change is in the middle of implementation of ranges equal. Ta-da, variable ranges equal. Let me know if you guys can't read these, if it's too small. Specifically, this is a helper function for ranges equal that gets called, hold on, equal 4. Where do I get called from? Da-da-da. Okay, if equal gets called with 2 pairs of iterators and sentinels, possibly a predicate and 2 projections as well. But if these are not both size pairs of iterator sentinels, but I can't subtract them to figure out how big the ranges are, then I call this equal 4 thing, where the 4 means it has to keep track of 4 different beginning and end points, whereas we could keep track of 2 begin points and a count in the other case. So that other one is implemented differently. We've touched equal 4 here. We've got a concept for test. If equal memcomp is safe and the projection is an identity projection, second projection is an identity projection, and both sentinels are unreachable sentinels, if we're comparing 2 infinite ranges for equality?
It's if either sentinel is unreachable or both.
Thank you. It's either, not both. That's a very significant difference, right? If one of these ranges is a potentially infinite range, then we don't need to worry about the length of that range or running off the end of that range. So we can just look at the other one. And we do one thing if the sentinel types are the same, which again suggests to me that this is the case where both ranges are infinite. Right, if one of them is unreachable and they're both the same, then they must both be unreachable. Oh, hey, tried to compare ranges with both sentinels being unreachable. We have an assert here. Okay. So if both ranges are infinite, we assert, which may be useful to users to know. And if only one of them is infinite, we just return false right away. This maybe, calling this an optimization is kind of interesting. It seems like a fairly rare case to me. I'm not sure that this is important to optimize for. Although it's only a cost in runtime throughput. I do believe it's correct, right? If any of the sentinels is unreachable sentinel, the ranges aren't equal because one's infinite and the other presumably is not. Although I'm not certain that that's even necessarily true, right? If we can create an unreachable sentinel, somebody else could do the same with a different type. So I'm not certain this is correct. Guarantee that unreachable sentinel or unreachable sentinel T, the type of an unreachable sentinel, is the type for every
Sun is so annoying. Yeah.
possible comparing two infinite ranges only for the side effects of the comparison project. This is useful. And circuit, no, short circuit is wrong. Would optimize that behavior away. Incorrect, that would be useful. Ignoring the correctness issue, even ignoring the correctness issue. I'm not sure these cases are worth the throughput cost. The handle especially.
So I have a question in the chat about the STL cert false above. What if you have two infinite ranges? So this is the case where both sentinels are unreachable. Now, obviously, if all the elements, like say two like infinite iota ranges that just count up and then start cycling around, obviously we're never going to hit the end. But what if you have a guarantee about your data that you're definitely going to find a mismatch element? Isn't that valid? But that STL assert's false. And then
Yes,
physically returns false, I guess.
that's also a reasonable. Yeah, the assert is, yeah, the assert that this is invalid doesn't necessarily make sense. Yeah. Their first elements even. Instead of using to compile.
Note that that is a runtime assert, not a static assert.
Oh, thank you. All right, off to an interesting start. Moving on, this is a helper function used to implement lexicographicalunpaircompare after the iterator and sentinel types have been unwrapped. Say if both pairs are size sentinels, well, we're not asking if both of them are, we're just testing that and giving a nice local name.
Well, there's 3 down here. So you just
I'm
have
not
to
remembering what memcomp classification pred is. It's right here. The type name of lexicompare memcomp classify : predicate. Okay, I think the metaprogramming design is that if this type is void, that we can't do any kind of special optimization of lexicographical compare. I'll have to go look that up probably in a moment. Okay, so if SC1IT1 is a sized or unreachable sentinel 4, and SC2IT2 is the same, and the projections are both identity projections.
trying to attack her.
Okay, we're trying to figure out the shortest finite length of these two, right? If one of them, if at least one of them is infinite and one of them is sized. Then we figure out the common length, and we want to do memcomp because we've tested that we can use memcomp here with memcomp classification pred. All right, so the optimization here is if one of the ranges is infinite and the other has a known length calculable in O1 time, then we're going to calculate that length and use memcomp to compare the known length of one range with the other range of infinite length as quickly as we possibly can. And either memcomp is going to tell us that they're different, or we're going to return on the basis of which range is the longer. All right, this seems like a valid optimization. At least, certainly this is much better than the last one. So let's just assure ourselves that the optimization is implemented correctly. This is generalizing the previously existing optimization that was only trying to apply memcomp if we had two sized sized ranges, right? That if we could calculate the size of both, and the projections were identity, and it was safe to use memcomp, we would use memcomp. This is stretching that out and saying if one of them is infinite, except this is actually saying if either of them is infinite, but both of them must be infinite or sized. Presumably the both infinite case is going to be very confusing to memcomp. We're going to tell memcomp to compare size max things. Yeah, I think that's actually valid. If both are unreachable, we should be comparing an infinite number of things. UB will ensue when we run off the end of memory, and that's okay, because the user lied to us by telling us they had two infinite ranges of things that fit in memory. Right, since the memcomp classification pred metaprogramming is going to require these things to be contiguous ranges, since otherwise it would be invalid to use memcomp whether they're infinite or not infinite. Yeah, I might have written this differently by defaulting num1 to size max instead of using if else and having it initially uninitialized, but I think that's a style question more than anything else. Stat min and min is usable because these both have the same type. Yeah, this behavior otherwise is exactly the same as it was before. I feel like this is correct. I think it's actually a useful optimization this time, which is very, very different from the first case. And I'm happy with everything here except for this warning suppression. Redundant code left and right sub-expressions are identical. This is very unfortunate. I assume this is due to a false positive from /analyze. It pays to be a little paranoid about suppressing warnings. So I'm going to ask the author for a little bit more info here. But otherwise, I'm happy with this this whole section. I think it looks good. And that's everything from algorithm. So let's move into memory. This looks like a similar change. This time we're looking at uninitialized copy result. There was already an optimization here for two sized ranges, right? Two sized sentinel fours, if they were both sized. And the magic metaprogramming said it was okay for us to use memcomp to compare them. Or sorry, memcopy to copy them. This is uninitialized copy. Then we would use copy memcopy common, which is an internal helper that does the right thing to memcopy contiguous ranges, most likely using memcopy when it can. So he's trying to generalize this once again in a similar way. Let's memorize whether or not these two things are sized. SE and IT are the right pair. OSE and out are the correct pair as well. The same metaprogramming, you put a copycat, and again using sized or unreachable sentinel instead of just sized sentinel 4. SEIT, OSE out, correct pairs, correct pairs. All right, once we've decided that we can apply an optimization, if both are sized, we just directly call copy memcopy common. This is probably exactly the same as the code on 83 and 84, the old code, except indented further. Yeah, it is exactly the same. Otherwise, if only one is sized, we call copy mem copy distance, which uses a count instead of using end iterators. Copy from I first to O first. Everything from I first to just next, I first, I last. Right, so if this is the size range, we could have, if it's sized, if we're performing the optimization in the first place, I think that means we know these are both contiguous. In which case, this could have just used plus instead of next. Yeah, I suspect here we use first plus I last minus I first. First to be contiguous, and already size 1 implies that subtract.
So I have a question about this comment. Is that a throughput consideration? Is it a performance consideration? I would expect, based on my incomplete understanding of ranges, that if we know that they're contiguous, but they could be like, user-defined fancy contiguous, even after unwrapping. Could it be actually slower at runtime if the optimizer doesn't cooperate to subtract the iterators, which could do a compile time, division by size to do pointer arithmetic internally, and then do an addition, which is a compile time multiply. Whereas if you call the ranges next, yeah, you go through the throughput cost of instantiating all the ranges machinery, but it should just return basically the last iterator. If like they're the same type. And if they're, some special sentinel that finds the size, then it ends up doing the subtraction and then addition anyways. I would know the answer if it was like classic iterators, but the ranges stuff is new enough that I don't know.
Yeah, give me a second. I think next is smart enough. All right, fine. I'm going to have to do this the slow way. I think next is smart enough that it's going to say, hey, these are size sentinel. I can subtract them. And then it's going to say, hey, the iterator is random access. I can add to it. I think it's going to do the same thing anyway, just after, expanding a lot of templates.
And wasting a lot of what I'm referring to is the case where the sentinel is the iterator type. In which case, if you say ranges next, I first.
Oh, I last, okay. In the case where the sentinel type and iterator type are the same.
Yeah.
then ranges next is going to just return the second argument. Yep. I believe you're right. I think that is a better optimization.
Okay.
Got
cool.
one of the ranges next cases.
I'm trying to develop my intuition for ranges
Yeah.
next. Thank you.
You're right. Let's trust the library. Trust the library. We put like 3 or 4 different optimizations into ranges next. It does the right thing. All right, we could, but we shouldn't. Let's delete this comment. Thank you. All right, similar case when the other range is sized and the first one is infinite, then we're going to copy I first to O first, but this time so first to O last. Yeah, I immediately see the uninitialized copy ought to have the underscore in it because that's the actual name, the name of the function that's being called here. Now the question is whether or not we believe it should be invalid to uninitialized copy 2 ranges that both have unreachable sentinels. This is a case where the algorithm technically would never finish, would never complete and return. I certainly can't think of a use case for doing so off the top of my head. I also don't think it's such a common thing that we should go out of our way to try to forbid it. But this looks like one of those things that we could forbid, and if someone comes up with a use case for it, we could back out.
I didn't catch all of Misko and Adam Bussior's comments above about the assert versus static assert, but I do vaguely recall there was a case with some completely other function where we had like put in a static assert to prevent it from compiling, or some other tech to prevent it from compiling, and users reported a bug saying, "Hey, I want my code to compile because I know that this branch will never be taken at runtime because of other user code that they have." Right. So I think we ended up backing down and saying it's going to be runtime assert.
About, yeah.
Yeah, I just can't remember what the what that context was.
I'm going to reply to this. Misko is suggesting, why are we using same as the concept instead of is same v the type trait? I'm going to point out that same as isn't significantly more expensive than is same v practice. Since is SVC. Yeah, we get a lot of nice performance benefits from having many of our type traits implemented in the compiler front end directly. so that we don't have to worry as much about throughput costs for metaprogramming where they're concerned. Anyway, I'll just comment. I'll let Adam Bussiard decide if he wants to call this resolved or not. So it can't use static assert, right? There's the exact case we're talking about. This standard doesn't say that it's ill-formed, it just, the behavior would be weird. So we don't necessarily want to reject it at compile time. Okay, let's squish that again. Yeah, having thought about this, I think I'm okay with asserting in this case until and unless we have a user complaining, argue that there's a desirable use case there. Moving to the next. We're implementing ranges uninitialized copy in, which is a sibling of uninitialized copy that copies objects into raw memory, but it does a counted number of them instead of having the input range delimited by iterator and sentinel pair. So I'm going to expect this one to be pretty similar to the last. We're just changing white space here at the beginning. The context per condition is where things will presumably get interesting. Footer copycat is exactly the same as before. We're doing sized or unreachable now. For the output. Because presumably, if we know the output is big enough, we don't need to check. Is that the idea? Yeah. Well, no, we're still calling copy min, copy common, which is a fun name. We can't have enough copies in the names of our functions. From first to first plus count, copy to O first to yeah, this again is taking advantage of the possible optimization where if this is a sized range, we can advance to it directly. And if it's unreachable sentinel, sorry, if it's an unreachable sentinel, it won't hit this case because this case is just the size sentinel 4 case. If it's unreachable sentinel, it presumably falls over here, in which case we just copy exactly count because we know that the output range has enough space. If it's infinitely long, it must have space for count objects. Right. Great. Okay, I'm happier with that now. And of course, the return code is the same in both cases. So this is once again a slight generalization of what was already an optimization for ranges of known length, where we're making it work with one of them is infinite as well. I think this again is correct. I'm happy with the optimization. And I don't think there's anything else to comment on here. Moving on to the next case. Uninitialized move in. This is going to be a lot like uninitialized copy in, except it's moving instead of copying. Except, of course, when putter move cat metaprogramming tells us the type is really trivial. Really trivial meaning that move for this thing is the same as copy anyway. So this code is going to look exactly like the code above, except it's going to test putter move cat. Right. If it's really trivial and the output range is sized or infinite, size case, go ahead and copy from first to first plus count into O first to O last. Infinite case, we know there are at least count things if there are an infinite number of things, so we can go ahead and just copy that many with copy min copy count. This is correct if the other one is correct.
Can you scroll back up to the uninitialized copy end? Was there a move of that OLast? Yeah, we got a ranges next there. Why is that different? That's copy mem copy common, which does that one assume that the types are the same?
Copy mem copy common.
I see it's pre-existing, but is this like a pre-existing bug?
That's a really good question. So this was effectively a change in the pre-existing code in this case. I first plus count and O first to
No votes for you.
let's go peek at copy mem copy common. Refresh our memory of what it does. Might be in X memory. It doesn't exist anywhere in the STL. Okay, no, it's there in X memory. All right, I take an input range and output range with iterators of the same type. That's what common means. OLast was the result of unwrapping last two. We were just assuming that it had the same type. Is this a pre-existing bug that's getting fixed? Since before we had types out and OSE for first two and last two, we were unwrapping them to O first, O last. The metaprogramming obviously doesn't know about the type of OLast at all because it's not involved here.
That's a good point. I did notice that the original code was identical, and now one is being fixed, but the other isn't, which indicates missing test coverage.
Yeah, this looks like a bug fix to me. As we were passing this to copy mem copy common, which requires these to have the same type. Pixie buggies always were great. Did you add test coverage to ensure we don't regress this again? Okay, zipping back down here.
Why am I taking damage?
It looks like this. If that was a bug, it looks like this has the same bug. Right, we're at it. Checking that these have satisfy size sentinel 4, but not that they have the same type before we try to invoke copy mem copy common, which expects iterator pairs instead of iterator sentinel pairs, I should say. Do we? Well, I'm not going to ask, do we? Shouldn't we? Better. Shouldn't we also? Yep, if that was a bug there, there's also a bug here. Similarly, we should add test coverage. Well, this one I'm confident is correct. All right, digging in further. Copy mem copy count is a new function. No wonder we couldn't find it before. We take an input iterator and output iterator and a count of things to copy between them, presumably using memcopy. This uses the ugly toAddress function that we added to unwrap, well, not unwrap, to convert these contiguous iterators into pointers.
Oh.
We then convert whatever kind of pointer that is into a pointer to char. Count of bytes between them is count times the size of whatever objects NIT denotes. Yes. And then we can call std memcopy, since we've converted everything into character pointers and the size of the object representations. That this is encapsulated here in this function instead of being done at the call site because it's so easy to mess up. Converting from a number of objects to a number of bytes. We do it all the time. If NIT is a pointer, specifically instead of a general contiguous iterator, then we can convert, we can directly add the byte count to the converted character pointer and reinterpret that back again into the type of ifirst, so that we don't necessarily have to do this plus. I'm sure this plus is pretty much as efficient. There's no division involved here, right? Which is the thing we don't like when we take the difference of two iterators. There's necessarily a division by the size of the objects to go from an address difference to a iterator difference in C++ land.
This is essentially reusing the multiplication because we have the unavoidable count bytes multiplication, but it is avoiding a second multiplication implied by the plus equal. It's super minor. I agree that we could probably get away with just plus equal, but I think Adam Bussier is doing this because in an earlier PR, we had mentioned the existence of this just directly past the character pointers because that was like a pre-existing optimization.
Right.
Right.
So we asked to preserve the difference of the character pointers instead of using the difference of the pointer to object types.
It seems potentially
I don't think we had a plus that we complained about before, but
right. It was. I think it was avoiding the minus that we really wanted to avoid because that's an implied division and that's a bit nastier. Here, I think it's reasonable to keep, mostly because I would be a little concerned about some program that calls these copy functions for like really short ranges, where it would be nice if it all boiled away down to memcopy and as few extra operations as possible.
Yeah, I'm happy with this. I don't know that I would ask for this if it wasn't here.
Right.
But given that it is here, I don't think it's worth the trouble of getting rid of either. It's a couple of lines of code extra to maintain, but they're pretty simple lines. So.
I think it might be worth replying to Misko, explaining the purpose. It's one. I wonder whether it deserves a comment, because it does look kind of weird. I don't know if I would ask for a comment, but it's possible.
Reasonable multiplication initialization count bytes. Very minor optimization at best. Very little extra code. It's fine to keep here. I don't know, how do you feel about comment? I don't think it needs a comment. It's obviously correct in both cases.
Mostly because we have this general principle of the STL conventionally avoids writing unnecessary code. So if you see something, there's probably a good reason for it. And in this case, like we're obviously going to some effort, and a little bit of thought reveals, oh, okay, you're really just avoiding the implied multiplication. I don't think it's so obscure that it deserves a comment. But again, if somebody added a comment, I wouldn't say, oh, we should leave this uncommented. I'm just like, okay, whatever you like.
Yeah, I'll just make the comment. This is what's happening here. If Misko feels it deserves to be commented with an explanation, he can ask for it, or he can just resolve this, and we won't have a comment. Yeah, I'm fine with that. All right, moving on. This is obviously just as correct as the other one was. The return is correct. I checked that against the in-out result aggregate. We're returning the right kinds of things. We're moving them because we're paranoid about the cost of copying iterators. Moving on, copy min copy distance. This dist IT is interesting. All right, let's figure out exactly what this is doing. This is taking 4 iterators.
I don't know how this mushroom didn't go off.
Possibly. We believe they're contiguous because we're converting them to pointers.
We can't hold away.
We're getting a count by taking the difference between D first and D last. And we're going to copy that many bytes from I first to O first. So this is formally taking 3 ranges.
Yeah.
An
Oh,
input range of
yeah.
objects, an output range of objects, and another range
Not
that's used
attacking
purely
I forgot. I guess.
to calculate distance. This is kind of weird.
Oh, I called out results and shit too, so I guess it doesn't matter now.
If IT is a pointer, we can recover the end. Again, we're using count. If not, then we have to divide count by the size of the objects. No except is correct because we require std2 address to be no except for contiguous iterators. I think std2 address is required to be no except for everything. So these are either contiguous iterators in C++20 and this calls std2 address, or these are pointers in some lower language version mode, and obviously converting pointers to pointers is no except. I believe that overload is superfluous. The only difference is how we get to count. So this is kind of strange. Let me go back and look at the call sites for this. As I kind of skimmed past it before. Copy and copy distance. That didn't work well. It's being called from uninitialized move unchecked as well. All right, so what this is buying at the cost of some iterator duplication is that it's encapsulating the calculation of the distance between these pointers. And it's doing so in a way that it can calculate the distance between char stars to avoid a multiplication. So there is a reason for having this instead of just calling the other version. It's a little weird. I don't know that it's terribly weird. I think these could be const. Just the 2 addresses, modify them. This function is sufficiently weird. But I think it deserves an explanatory comment. I don't know that this is the only place in the STL where we pass a range around that we don't intend to actually look at the contents of. But it's certainly the only one I can think of.
It does seem unique. I can't remember another example where we've got sort of like template range that we only get the distance from. I think with a comment, it's good. My one concern for this function is the variable named count is actually a count of bytes. And I think we should be consistent with the previous function that called it count bytes. This is like the one time that we have something that's not in the type system, whether it's bytes or elements, and our strong convention is if you just see a count or a num, it's always elements unless it says bytes. Apologies for doing a review through your fingertips.
No, that's fine. That's fine. I don't mind, which we've called count bytes, count of bytes, count bytes. Good comment. Thought more about determining count by the right method and passing that around. In theory, we could extract this behavior into another function. But that would require us to have a copy mem copy count that takes account of bytes. No, I'm happy with it as it is. Extracting the distance behavior from this function would either produce a sufficient code or something even more confusing. All right, moving on. Uninitialized move unchecked. This is an internal only function. That takes iterator sentinel pairs that have already been unwrapped and moves objects from an input range into raw storage in an output range where objects are being created, move constructed, to be precise. Looks like, again, we're generalizing a pre-existing optimization that was valid for sized input and sized outputs to also work with an infinite output or apparently an infinite input, which should keep things interesting. Let's make sure that the types match up correctly. They're using the right pairs, and they are. Oops and out. It's an unfortunate combination. All right, if both are sized, we should have exactly the code from before. Copy comment, I first, ranges next. I first is stiff move I last. Just next, yep, and we do. If range 1 is sized, then range 1 is confusing. If the input range is sized, which implies that the output range must be infinite since they aren't both sized. Then we're going to call copy mem copy distance from I first to O first with the distance calculation using I first and the result of next I first, I last. Yes, use the size of the input range. Assume that there are that many, there's space for that many objects in the output. And that's the right thing to do. If the output range is sized, which suggests that the input range is infinite, this doesn't seem like correct behavior to me. If the input range is infinite and the output range is sized, we uninitialized move only enough to fill the output. So if the user wrote a bug trying to initialize an infinite number of objects in a finite range, we hide the bug.
What does the standard say when the sizes differ?
I think maybe the standard actually says this is what we're supposed to do, that we take the prefix that fits. Uninitialized move. Sorry, that's the stood version. Preconditions, no overlap. Yes, the standard says while at least one range is not empty. Which is the behavior that Christopher DeBell and I decided was probably the best behavior for such two-range algorithms, that it should work on the common prefix where the length is. Sorry, it should work on the prefix of the two ranges that exists and has the same length. Which is okay in the case of ranges algorithms because we always return the ends of both things where we stopped working. So you can continue working, you can tell if we consumed all the input or not in cases like this. All right, so this is correct because this is the same behavior we do with finite ranges, regardless of whether or not they're infinite.
I think it makes sense for like copying an infinite iota range to a finite output. You don't care that you're truncating after 100. You just want to fill.
Well, you may care if truncating after 100, but that's okay because we let you know if we truncate or not. Right.
You get you don't drop it on the floor.
We preserve all that information, unlike the stood algorithms that sometimes drop things, and you can't tell where they stopped working, which would be very bad. But anyway, all right. So this is fine then. This is just using the output to calculate instead of the input to calculate the distance. I believe that's also correct. Again, I would like to have the actual function name here, uninitialized move _move, instead of tried to uninitialize move as if it's a compound verb phrase. Is kind of confusing. I wonder if 2 infinite ranges would be better than 2 ranges with unreachable sentinels here. I guess we do precisely know that it's 2 ranges with unreachable sentinels, which is a subset of all possible infinite ranges. So it's a little more specific of an error message. Yeah, I'm fine with that. All right, and again, I can't think of a use case in which we would want to allow uninitialized moving an infinite range of things into an infinite output. So that falls under we'll wait for a user to complain if they believe there is a valid use case for it. Case that I suggested earlier. All right, moving on. Here's the actual definition of sized or unreachable sentinel-4, which, unsurprisingly, is exactly what I was expecting it to be. either size sentinel or the sentinel type is the same as unreachable sentinel T. Find unchecked. This is a helper function used to implement find. It's also used directly in a few places in other algorithms that want find and have already unwrapped iterators. So this expects to be called with unwrapped iterators, that it doesn't need to unwrap further. There's a pre-existing optimization here again for size sentinel 4 that we're generalizing to size or unreachable sentinel 4. All right, we're keeping track if it's actually size. If so, we have the previous code verbatim. Otherwise, try to find a value in a range with unreachable sentinel that is not within limits of range's value type. I'm missing something here. I'm not getting right off the top of my head why this is invalid or should be invalid.
So this is a case where we can detect that we're never going to find the thing. This is like if your range is, was it a range of
not within
unsigned
limits.
pair? Yeah, not within limits.
All right,
yeah, so we know
within limits is what's throwing me off.
Yeah.
This not within limits is a function that determines whether or not the value type that this iterator denotes can represent this value. I would have used representable in that name somewhere. Okay, that's good. Thanks for the reminder. So we know it's not going to be able to find it. We just return the end of the range, which is the iterator, sorry, that corresponds to the sentinel that denotes the end of the range. We can calculate that directly with ranges next. In the sized case, in the case where it's infinite, we know we're not going to be able to find the end of the range. I don't know that we just want to assert here. Yeah, that's fine. Try to find a value in a range with unreachable
She's for sure going to be standing there long enough to get slowed for one shot.
I'd like this to be it cannot be represented by the range's value type. We talk about representable values a lot in standard ETH, so people may have seen that phrase before. And talking about limits so near the word range makes me think, it means the limits of the range that begin and end. All right,
I was thinking, I wrote that within limits optimization like a few years ago, and then I realized, wait, that was like 2011. That was a decade ago. This range technology is so much newer. Yeah, we implemented this a long time ago.
I guess I just missed that one up until about a year ago. I know I've seen that sometime in the last year or so. Anyway, all right. So if the thing is representable, then we have two different behaviors. If the range is sized, we calculate its size and call that count. Otherwise, we let count be size max, because we're going to eventually call memchar, C STL memchar, with that many things. We'll let memchar keep looking forever in the case of a unreachable sentinel, which is the correct behavior to do. Get UB if it's not actually found before terrible things happen and we run off the end of memory. All right, I believe this is correct again. I have no more comments on this, but I'm happy. Okay, we've made it through a whole bunch of optimizations. We're now moving on to test code, starting with equal. We're in the ranges equal test. We have only, this is what, a straight smoke test function. We're using begin and end and unreachable sentinel. Okay. Just a simple test case. 2 arrays. Basically, this is testing the condition he had, that if one of the ranges is infinite and the other is finite, they obviously can't be equal. And we've got a left-hand case and a right-hand case, which I feel like is probably sufficient coverage.
I don't know.
If it worked before, make sure there are no other weird cases in the code. This is lexicographicalunpaircompare. Yeah, there are no other branches in the code that aren't being covered. Simple test, simple algorithm. I think this is adequate coverage. If we do want that, I think the test is correct. We've got kind of a simplification of pre-existing code by merging these two things together, that we're using the same array of 5 integers. Trying to find 1 in there works, trying to find 10 in there doesn't. And in the case of unreachable sentinel, trying to find something in that infinite range of integers does work. All right, I know there are no other weird cases for find, so that looks like adequate test coverage. Lexicographicalunpaircompare. This is obviously going to need some more test coverage. We've got 2 actually finite arrays.
I don't see us.
We're passing the begin and end of this array, and the same thing, but an infinite version thereof. Yes. So technically, we've got an array of 3 integers and an infinite array of integers whose first prefix of 3 happens to be exactly the same. So the algorithm should actually examine the 3 to determine if they're equal and return true, because the second range, the infinite range, is longer. That's how lexicographicalunpaircompare works. So if we switch the ordering between the infinite and the finite length ranges, it returns false. The opposite case, we have 2 non-identical infinite ranges of integers, right? Since they differ in the third place, this is going to be a call with the find behavior. We don't flip it. Do we have an R2? No, we don't have an R2, R1 case. Array 2 ordered before array 1 case. We compare infinite with empty. We compare empty with infinite. Oh, because he's changing. Sorry. I'm looking at this line and trying to figure out why it's exactly the same as this one, but has a different result. It's because we're changing the test data. Sorry, so if we change the only one that differs is 3, so that it doesn't differ anymore, then we should get different results than the results we had before. Test empty with infinite. Here is still the same, regardless of the content of the infinite range. And if we set it to 1 so that it's less than the 2 over here, then R2 should be ordered before array 1. We compare them infinitely, then yes, we get that array 1 is not less than array 2, as expected. Infinite and empty, empty and infinite. Oh, sorry, this isn't empty. This is finite and infinite. The same case as here, but the opposite result, because now when we get to the third position, we discover that the second array should be ordered before the first, regardless of length. Okay, I'm happy that these test cases are all correct. I believe we have all the coverage we should, right? We have both infinite case. We have finite and infinite. We have infinite and finite. We could have some empty range coverage, but I'm not really concerned. Empty is a special case of finite. And I know we have coverage elsewhere for empty ranges for this algorithm. So I feel like this is sufficient test coverage as well. And he has clearly commented here that we're validating the comp behavior. Moving on to uninitialized copying. We're using vectors today. All right, we're going to call uninitialized copying with the beginning of this vector. We're going to say we want to copy 3 integers from this to the beginning of this vector output of infinite length. And luckily, infinity is greater than 3. So there's plenty of room. We're validating the result type is uninitialized copy in result. Iterator type of the input vector, iterator type of the output range. They both happen to be the same, so it's not very inventive, but yeah. That is the correct return type. We assert that the end of the processed input is the end of the input range.
Oh,
Uninitialized copy in should be copying 3 things. In which case I'm greatly surprised. Oh, sorry. We assert that one passed the end of the processed input is the end of the input vector. That is much more correct. But maybe a peculiar way to test the result. Did we do that with other things in this test? Yes, we did. We asserted that result was 2 away from the end of the input. All right, he's maintaining the existing style, which I find slightly confusing, but I won't complain about. And similarly, we used to up 3 elements of the output range. We assert that the input hasn't been changed. And output equals expected output. Most likely is correct, but let's go check what expected output is. 1355, 12345 minus 1. So yeah, it checks that the 3 integers that are supposed to be copied were copied and that this one was left alone. All right, that's correct. And again, this one didn't have a whole lot of complicated cases. So I think that one's good as well.
I couldn't tell the difference.
Let's move on to the last one really quick here. And then I'll go scan for questions. Validate unreachable sentinel. We're calling uninitialized move in and asking it to move 3 integers from the beginning of this vector to the beginning of that vector. Return type is uninitialized move in result. Correct. We assert that we process 3 elements from the input and 3 from the output. That the input is unchanged and that the output has the expected result. All right, this is much like the other tests, so easy to verify quickly. Now let's pop over and see what's been going on in chat.
There's a bunch of unrelated questions, essentially office hours. I had some initial questions, but they were addressed by the very exhaustive test for the lexicographical compare. And you mentioned the stack analysis warning that I think should be transition if it is a real bug.
Oh, yeah. All right, I'll add a comment for you so you don't have to. We should file a bug. Transition. Okay, save you the trouble of submitting another review. All right, so no questions? Yeah, we're talking about unrelated things. And dead cows. No is less than all other pointers. Is that true?
I may or may not be spreading lies in chat. That's what my brain said. But because my brain has the total order. Yeah, I don't think it's guaranteed. I had to go look up the standard days.
Relational operator.
It does not seem to say anything about that. I think I was probably confusing it with null opt, which the standard actually does specify the behavior very strictly. Here it's got the usual stuff about, oh, it's unspecified.
Yeah. Otherwise, neither pointer is required to compare greater than the other. Unspecified. So. But for implementations like ours with the flat memory model, where no pointer has the 0 address, then yeah, it's obviously going to compare as last. Okay. Any questions? Everybody happy? I'm happy.
Incredibly happy.
Okay, I'm going to finish my review. I'm going to request changes because I think we had some actual questions about the correctness of the first one, although most of it was great. And thank you all for coming. I hope you had as much fun as I did.
I'll stop the recording and transcription. Thanks, everybody. See you next week.
Thanks, Casey.
Yeah.
I learned a lot about unreachable sentinels. This was very useful.